Hey guys, and welcome to week 6 of the wrap-up of week 6 for Contextual Electronics. We have 2 weeks left, and we're pretty deep into the build, and we've started programming and building and struggling and having lots and lots of fun. So we have Nathan and Pedro and Wes here today, and we're going to talk about the progress we have, and I'm sure that we'll talk a bunch about the stinker of MCP 3901, and we'll talk about the programming and everything else. So let's go down the line. Wes, why don't you start? How's your build going?
Things have been going pretty good. In the week that you were sort of traveling, I did succeed in getting the DAC working. I think to spec, and then have tried to do a little bit of other work on some of the additional components, and that's where I've been having some frustration and cursing a little bit at the ADC, but it's been a great learning experience. It's when you have the problems that you really dig down and learn something new. So I've learned some stuff.
I think it was you that found the lack of an oscillator as well, right? Which I was surprised by, and yet not that surprised by. These kind of problems are always lingering there.
Yeah, there's been some other things that I just, reading through that data sheet a couple more times, I realized that, yeah, I misunderstood that completely. I'm sure if I read it again, I'd find a couple other things that I screwed up. But, hey, that's next time, hopefully, dealing with a part like that, you would know what to look for. Or I would know what to look for.
You never do. I tell you. It's like you can never get as deep as when you, like you're saying, like when you're actually struggling with it, that's when you're going to make the most of the details there, right? So you can gloss over something and say, oh, well, that probably matters, but maybe not. And then when you're in it and you're like, oh my God, that definitely matters. Like that's when it really starts to go poorly. Cool. Pedro, how about you?
I managed to glue down the ADC. I haven't tested it yet, just home out all the legs and adding an electrical contact.
Cool.
The DAC, I have been struggling with it a little bit. Got those weird spikes that pop up. I quite haven't found it. The problem. What's the problem? I got quite confused without power. So 5 volts are not there, and I'm getting the DAC to give me an output. That's quite confusing.
So the DAC's giving an actual like DC output when it's just plugged into the USB.
Just with the Arduino, and the diode is there, so no power is spewing through from the Arduino. I measure the input of the DAC, the power, and it's at ground. It doesn't have any voltages, and I have an output. So it's quite confusing.
Yeah, we'll have to talk about that.
Like that, no spikes. It's a perfect output.
Huh. That's really weird.
Yeah.
Okay. Well, we'll talk a little bit more about that in a second here. Nathan, how about you? How's your build going?
So, for me, my major troubles is basically time management. So I get to watch the videos during the week, but I only get a little bit of time on the weekends to do all the building. But the soldering it's a bit fiddly this time around, but I'm pushing ahead. But the proof's going to come in all the testing, and I've got a bunch of testing I need to do from about the DAC onwards. So, but I'm right up to speed on one board with all the soldering.
Okay, that's good. Yeah. So you've been doing like the module testing at each point, or are you kind of assembling all of it and then testing at the end?
No, I tend to do it as you finish a module. I move on, I finish a module, do the testing if I can. But this last week and a bit, I left everything, so I've got to go back from the DAC onward and move forwards with the testing.
Yeah, that'll be an interesting comparison too. Like, so, because as I mentioned in the past, like I used to do that where I'm not sure if this is the exact same as what you're doing, but I would assemble a whole bunch of stuff and then I would test it, and then that would always be very dangerous because then I would have something happen and I didn't have any, it was basically system level effects, whereas I should have been testing on the small DAC side of, the small module side of things. And so like the progression wasn't there, so I just kind of had to figure it all out. Usually what ends up happening is I rip everything off and start again. So hopefully you don't have to do that though. And it doesn't sound like that's quite what you're doing either. So that's good though. Okay, so you're up to the DAC. Seems like most people are through the DAC. So Wes and Pedro, you guys both have gotten the MCP 3901 at least down, right? Which I actually have not done yet. I have not. I've gotten, I've done the flush cut and I've gotten some the test one, but my production level board is still stands ADC here. So you want to tell us a little bit about your experience with the getting the MCP 3901 down?
Yeah, so I tried 3 different methods on that. The first time was folding the pins under, and that was probably the worst experience, because what happened is I just couldn't get the soldering iron down on the pad, so the solder would stick to the pins but never go down to the pads, and I would always have a couple that wouldn't connect. The tippy toe method that Pedro has done, that actually worked pretty well. There was a little bit of leeway to adjust the pins if they didn't connect down. And the flush cut also looks, I would say, out of the gate, I had the best results doing the flush cut, but I still have like one pin that didn't connect, and that's just a pain.
Yeah. I think it was Josh Wizzy on the forums. He said he was using hot air with the flush cut, and once you have, basically hot air is how I would have done this any other time, right? Drag soldering is interesting, but it's not the optimal way of doing things, and that's always nice, because then you kind of can put some extra flux on there and basically blow in there with hot air, and then with the hot air it basically kind of levels everything out, kind of like reflow. So Pedro, author of the tiptoe method, why don't you tell us about your experience?
Yeah, it was how do I call it? I was watching your video when you suggesting folding the legs under, and I was folding the legs under, and halfway I look at the part and interesting. It was like that.
Yeah.
So I put it down on the board, and I can get my soldering iron there. So I jiggle it about, and oh, one side is done. Let's try the other one. The other one was a bit harder because I pushed the part too far to the regulators, but it took about an hour of wiggling it about, and it connected. So it was an interesting thing that happened.
Yeah. So when you say, so I don't know if I saw pictures of from the top down for yours, but you're saying that the legs have that natural curve to them as well, right? So
yeah,
if it's they're normally like this, do they go straight to 90?
No. I kept the wiggly bits. They just fold halfway, then they have that natural curve.
Yeah. Okay, so it's the same kind of thing that Wes was saying, where you have more access to the actual pads, right? So you can actually get heat under the pads.
Yeah. The legs naturally are something like that, right?
Yeah.
I bent them like this, so you have some leeway to get the soldering iron to touch the pad and the leg.
Yeah. Right, and that's actually what's going to cause the solder to climb up, right? Is to have heat in both places and have it wick up the leg. Yeah, that's good. Yeah. Did you guys have you been using the no clean flux as well? Or the no clean flux pen.
I got one that is no clean, but it's rosin based.
Okay.
And I have some old flux that's sort of a paste, and I've had some better success with that for some of the extreme kinds of things here I've been trying to do.
Yeah. Yeah, I've been. I just got a bunch in yesterday that I haven't tried out yet, so I'll be trying that today. I got a whole bottle of like a refill for the pens. You know, you can refill those. So I got a bottle of that, and then 2 different types of rosin. You know, just rosin straight up flux. No, not the no clean type. So it's not alcohol based.
One of the things that I use with the no clean flux is I will dip the tip of my solder wick into it before I go to pull it off, and that helps a great deal trying to wick off solder. Just because I think the solder wick has some resin in it, or rosin in it, but it burns out pretty quick, and so just dipping it in there has helped. That's the biggest thing I use it for.
I have a separate set of solder wick from the ones that we suggested, and I've tried that, and there definitely is a performance difference. So, and it has a much it has that same rosin powder in there effectively, and that thing works much better. So that might have just been a bad suggestion on my part, unfortunately. So okay, and then Wes, tell us a little bit about the. Oh, Nathan, sorry, did you have something?
Yeah, so I've done both my MCP 3901s, and I did a short video that I've put up on my build log that you link off onto YouTube on, just showing what I did there. I'm with Wes on the Wick. Yep, I just plaster it with the stuff and then put it in there as well. So it's fiddly. The only lesson I learned was when you bend the legs, you've got to go back in and realign the legs again, because they will either concave in or convex out. So
definitely, yeah. I've noticed that. I've probably soldered at least. I've got 4 parts down. I've done 4 parts. I've probably redone them about 2 or 3 times now, just kind of trying to see all the different ways to do it. And yeah, if it's not linear, right? If it's not that straight across type of thing, you start getting like that's what's great about when it comes from the vendor. It's already nice and flat. You know, if we had the right footprint, of course. But yeah, you guys have been doing great with that stuff. Nathan, which method did you use?
I did the original, the bend under. When I started bending the legs, they, you get a bit overexcited and you bend them too fast, and they just naturally go under anyway. So I noticed they're very thin, so I didn't want to try and bend them out again just in case they broke off. So I just went with the bend under. But you do have to use a little bit more solder on it so you can catch the, because it leaves a small gap when it bends under, just because it's concave under. So you got to use a bit more solder, and then I've got to go in with the wick afterwards just to remove the excess stuff.
Okay. So that seems like a common theme for all of you, that even though you were soldering it, you do drag soldering, but then you also had to pull some out just for getting the heat conduction with extra solder and stuff like that. Okay. Wes, what about so you were the one that rigged up that oscillator circuit, is that right?
I did. I was just trying to find some way of testing the ADC before I got the crystal from DigiKey, and it sort of worked. It was enough to at least tell that the thing's alive. I'm not sure that it was giving me stable outputs, but it was something other than zeros. So that was sort of good. It basically was just several NAND a buffer and a NAND using a quad NAND pack, and it just sort of fed back into itself. And then I ended up putting an NPN simple, I think, an amplifier on the output of that to give it a little bit more drive strength into the ADC.
Okay.
But I think trying that out, I think I ended up burning up my NPN transistor. I don't know what happened there, but everything sort of stopped working, and I reached over and the thing was like really hot. So I think I shorted something or something bad happened elsewhere in my circuit.
Okay. Yeah. Yeah, it is always shocking when you touch something and it's like, oh, this this may no longer work.
Yeah, I think maybe 1 megahertz is a little high frequency for the particular NPN I was using.
Interesting. Okay. Okay, cool. So Pedro, you've had the same issue that I've had. Have Nathan or Wes, have you guys seen this where if you're plugged in to the USB here and then running it, it has some other kind of noise in there? It has like, it looks like it's oscillating or something. I mean, on the input, I don't know what it is yet.
Well, I chose not to put in the 0 ohm resistor to power the Arduino from the bench buddy. I didn't do that, so I don't have the diode in place, and I haven't seen anything quite like you're seeing.
Okay, yeah, that's a good test then, because that might still be back biasing up to the board or something like that. That's so Pedro, you said that you thought it might have been pushing power over SPI. Is that what you're saying?
Yes, something like that, because the power line was there, so the power had to come from somewhere else, right?
So what is the output that you're actually seeing a DC level on the output? Is that right?
Yeah.
The DAC out.
The programmed level from the one that is on the software. I was trying, as you suggested, to measure the higher loads, so I put in like the maximum to test, and I started pulling back down, and then I realized, this isn't connected. Why am I getting levels? But connected. So.
I wonder if the chip select might be also powering it, because I have seen something similar. Not the noise, but I have seen some output from these chips even when the bench buddy wasn't powered. And yeah, maybe the chip select and some protective circuitry there that's feeding back into the chip to power it through them.
Yeah. So you're thinking that the chip select, because it's normally high, right? But this is just happening on the DACs. Is that right?
Yeah, so forget chip select then, because it is normally high, but yeah, I don't know. But I am seeing some strange things too.
Okay. Yeah, this is interesting. Well, especially because that's a good point about what you said about not connecting it together, right? So we still, I mean, basically what we're dealing with here is we're kind of connecting together power and grounds, right? This is always where a lot of these issues come in, because we have a couple different grounds as well, right? We connected the input to the Arduino, right? The raw input is coming from our 12 volts from here. So there are some places that this could start to get messy, of course. So yeah, we'll have to keep an eye out for that, because I've had some weird behavior. I haven't characterized it well enough, but it was mostly that noise. I mean, you saw in that video when I took the noise, when I was looking at the DAC output, I saw this odd signal. I unplugged it from the Arduino, and then it was good. So could be ground loops or something weird like that. Okay. So we'll have to keep going with that kind of thing. How's the programming been going for you guys? It's been okay? I mean, I know that my programming skills are not anything to be writing home about, but...
You got me screaming at the screen. Don't do that.
Yeah.
And then you fixed it.
Okay,
You were listening.
Yeah. It's not my forte. I have to say, I mean, so I've used Arduino in the past just for basically what we're doing here, exercising chips, throwing small SPI commands, basically nothing really sequenced, just kind of one-off commands, trying to get things configured and set up, and getting through the different modes to test things out. And like Wes said, that's when you kind of really start to dig into the data sheet more, and you start to really find those corner cases of what you probably should have tried to find in the past. So aside from my terrible programming, you guys are all well versed in programming. You guys are okay with that stuff?
Better than
not mine, Chris.
What's that?
Yeah, not mine, Chris. I haven't done a lot of programming. Spies this time around. Spies the first guy I've had to go with it. So
okay.
It's been entertaining. You've done quite a few mistakes that I've done as well. So it's I'm happy to see other people suffer as well. Okay,
good. I'm glad I can offer that as a service. Suffering as a service, right? SaaS. Yeah. Okay, cool. Well, that's good. Yeah, and you know, getting into SPI is kind of awkward sometimes. You know, trying to figure out obviously the lines are switched on here, so we fix the lines on the back side. So that's one thing that happens a lot, and you know, trying to figure out MSB, LSB type stuff. You know, especially with multi-byte things. So that's always a tricky thing to get used to with SPI. The other thing, I'm a little disappointed about the Gabotronics thing that we can't actually monitor, because that would be useful to have like decoding. So we might have to rig up a circuit kind of like what Wes did on a breadboard just to have a level translator. So I'll be putting through another order on Newark probably for some final parts, and I'll make a video about that and all the other things that we might want to have in that final order. So.
Yeah, just on the Gabotronics, because I've got the portable version, it is actually 5 volt tolerance. So I'll see what happens there.
Okay. Did it? Yeah. So I know that. Yeah. So Gabe, he basically uses that same module that we have, and then he put some other circuitry around it. So he did the same thing with like that AC. You know how we built the AC probe. He just did that internally with a switch in the portable version, which has the case and everything. Nathan, have you opened it up at all? Have you looked inside, or is it just a resistor, or is it actually a level translator?
No, I haven't opened up that. not that game.
Always should open up your test equipment, right?
No, I did take a look at the schematic though, so I could see that there. But I guess that's a challenge. I'll have to go and open it up.
You don't have to, but it's it would be interesting to see how, because I mean, so Gabe wrote it in the manual that's either a 3K resistor or a level translator. So I think if we build a circuit, we'll build a level translator to do that kind of thing. But hopefully we won't have any problems with the MCP 3901, right, guys? What could possibly go wrong? Okay.
One of the things that I guess John just posted on the forums was that if you're using the standard SPI library, that 10-pin or pin 10 comes into picture as maybe the default chip select, and it's actually going off to someplace else for our purposes. It might be worth like taking anyone watching this taking a look at what John had found out. I don't know if that might explain some of the oddities that folks are seeing. Because I'm not using the standard SPI library, it could also explain why I'm not seeing some of this other noise.
Well, I guess it depends on which library you're using, because there's the actual compiled C++ library, which actually talks to the registers for the SPI stuff, and that's like SPI.transmit. I think it's transmit. That's basically just pushing that to the registers. You don't necessarily have to. I don't think you have to turn the chip select on manually. Every example program I've seen, you turn it on manually and then you hit transmit, where you actually, and basically all that's doing is anything within whatever you're sending to the function, it sends that byte. It's a single byte send, and then the return is also a single byte. So if you do return, well, not return, but return equals, and then SPI.transfer, and then whatever you're sending, send in the brackets, right? Basically, it's going to also pull back in whatever that return function is. So Wes, you're doing it all custom though, right?
Yeah, I just started that way and have kept going with it.
Okay.
But yeah. I just looked again. John didn't say he was using another library, so I don't know. Maybe he's done something else there that you haven't done. And I actually haven't explored, all the nuances of what that is doing either. So,
Okay.
I was under the assumption of what you said was true, but it seems like he's seeing some other behavior.
That's interesting. Yeah, so the pin 10 is actually what we're using for the PWM output. So if that is the case, that actually could be quite detrimental, because basically what we'd be doing then is it would basically be toggling that Q2 FET on and off. Oh, I see. Okay. So that could be a problem there if that is the case. So I hadn't seen this post yet, so I'll take a look at it in a little while. And
something at least to rule out that really isn't happening in your case.
Yeah.
Like I said, I haven't tried it yet.
Okay. Yeah. Okay. So what other questions do you guys have? Obviously, I think Wes, I think all of you guys might be ahead of me with videos at least. So I can answer questions for what I know.
So I've got one that's not necessarily about building stuff, but there's only 2 weeks to go, and what's going to happen to us after the 2 weeks? I'm relying on on the support I've got, and it's going to be empty after 2 weeks or not?
Like the forums?
Yeah, like the forums, yeah.
Oh, no, you guys have lifetime access. You can keep going on the forums for as long as you want to. So after 2 weeks, so basically, as I said when we started this, after 2 weeks, if we're not done, I'm going to keep going too. I mean, this is my not job now, guys, right? I mean, so I wouldn't worry about that. We can keep having hangouts. We can keep doing that stuff. I'm really not worried about that. I really am interested in getting this thing up and running, and even past that, we want to do additional changes to this thing, right? So if we want to keep moving along as a community-based project, we should talk about that stuff as well. So don't worry about the 2 week thing.
I was also one of the guys that started off using the Leonardo as well. So to finish this off, I went back to my Uno just to keep up with the SPI interconnects as well.
Yeah, so that was surprising to me actually. That I thought that the standard interface was pretty standard with the. So you're saying that the SPI pins are different on pins 10, 11, 12, 13. Is that right?
They have a separate breakout header for the SPI lines.
Which is really weird to me. So thinking about it, so it's different than the ICSP. Like this, is this the header you mean here? This one?
Yep, that's the one. Yeah. Yep.
Yeah. Yeah. So it is doubled up on the Uno boards or whatever this is. So this is a 2010 from Freetronics. This is a copy of the Duele Mininova, however you say it. So it is similar on all those. I'm not sure why the Leonardo changed, because I thought that was pretty standard across all of them, but that must have been my mistake on that. Leonardo was later, right?
Yeah, and I don't know too much about the boards, but they brought in that extra mini micro for the USB stuff.
Oh, okay. So maybe there's something with that where they had to think. Okay, yeah. So I guess going forward, I would recommend that we future classes that we do with Uno. So that would make sense. I have a question for you guys actually. So if all things were being equal, if you took this class again in the future, would you want to know about? Would you want to have the same problems that we're having, right? I mean, Wes, you mentioned we're learning a lot like this. If this was scrubbed up and redone, do we lose something there?
Now, I remember a conversation that you had on the AMP hour with Dave about whether or not you were going to intentionally introduce problems or not. And in the back of my mind, every time something comes up, I'm like, is this Chris being evil, or is it something that we really missed?
No, this is Chris being Chris. This is just. I wish I was that dastardly and evil, but no, I'm just a schlub. So yeah, this is just sad. It happens,
But
So Chris, for me, I call myself a retread, so I've been away from the industry probably 15 plus years now. Coming back in, I much prefer this where you go along, you do your design, and then you just come across logically all your problems. I've learned a heck of a lot in 2 minutes worth of watching a movie, because it just triggers the oh, that was that in your mind, and I can get through it. It's just a lot more valuable this way. Not necessarily surprises. Some of the surprises are a bit painful, but that also reminds me of how it was in the day as well.
Yeah. Okay. Pedro, you're gonna buck the trend and say, Chris, you're an idiot. You shouldn't have done it like this.
No. It's fine like that. But for someone that comes after us, maybe the footprint should be the correct one. But,
yeah, maybe we can
all
save
the
a little
other stuff, it's
time.
just fine.
Yeah.
Yeah. Time and parts.
Yeah, the only two things that I probably wouldn't want to subject future classes to there was like maybe the footprint problem with the ADC. I think that's just unusually cruel.
Yeah.
And then maybe even the footprint problem we had with some of the high tolerance resistors on the other side for the instrumentation amp, to fix those.
Yeah.
Everything else has been reasonable kinds of workarounds.
Yeah.
Even swapping the master slave pins. I mean, that would be one I think to leave. You know, it's an easy enough fix. You've put enough 0 ohm resistor spots in there and things of that sort, so that you know, you can fix some things after the fact by just changing the values that you populate those with. So,
Yeah.
but the footprints are the ones that are really annoying.
That's always painful. If you ever had a one thing I'm glad we didn't do is if you've ever had a mirrored footprint. Have you ever seen those before? Where it's like 4 pins, but then it's actually like this kind of thing. You have to do like jumper. If it was ever like that, the whole thing, it would just be all over. You know. It's so okay. Yeah, that's good. That's good input. So we do have a question here from James. He said, fan PWM questions. R61 still 0 ohms. R61 is at the bottom. Let me pull that up actually. I think it's the bottom side of the Q2. So if we,
1 year defeat.
yeah, I can do screen share. So if we zoom in here, it is R61 is still 0 ohms. And we had talked about that at one point, possibly doing this as a divider, having this as an optional divider here. But I think ultimately what will happen is an enhancement will need to change. So we have the gain that can go up to 4 volts here, right? And so if we want 4 volts here, we want a little bit more fine control. We'll actually change this resistor here. And the only downside to that is I think I misspoke when I talked about that. I think I said that we would go less. No, that is less, right? So if we went to a 1/4 ohm instead of an ohm, right, then 4 volts would be 1 amp through here, and then 2 amps. So basically, if we start going lower and lower on the resistor here, we should get more fine control in terms of steps, because then it would be like an 8-to-1 mapping, right? So if we have, say this is now 0.125 ohms instead of 1 ohm, we have 4 volts here, that would translate to 1/2 an amp through here, right? So 4 volts, you want to see 4 volts here. Oh no, that is the wrong direction. I'm sorry. Yeah.
Yeah, I think to get you need to go up
that direction. That's right. Yeah. So we need to go up higher. Sorry. So if we want 4 volts here, right, to match 4 volts here, this would have to be 8 ohms then. And the only downside to that is basically if you go up in ohms, right, so then we start becoming subjected to power problems, because you think I squared R, right? So that's power equals I squared times R. If you have 8 ohms here now, if you have 1/2 an amp squared would be 0.25 amps times 8. So that'd be 1/4 of 8, so that's 2 watts through this resistor then. So to do so, we might have to do like resistor stacking or something similar like that. So it'll be an interesting, we'll have to do that calculation at a later date, but you know, if we do want to get more fine control, we'll have to deal with that. I don't know, do you guys have a feel for in terms of applications, if you'd rather have more fine control over lower currents, or if you'd rather have access to higher currents?
Well, I ended up putting a 1K resistor into the R61 spot, and then that sort of works with still with the 1 ohm and limits the max current through that output to half an amp. That just I wanted to do that just because with the PTC thermistors we have and the power limit on everything else, it just sort of made sense.
Sorry about that. I have a dog in the room with me. Sorry, keep going.
Yeah, I was just saying I put a 1K there, and that ends up being a voltage divider that, so feeding into that op amp, it I think maxes it at half a volt, and so that allows up to half an amp on the output there. That was just a choice I made when I was putting that in. Half an amp was good for me for the purpose of getting it working, and without burning anything up with too much power or current going through it.
Okay. So then you're not going to actually use that as a PWM then, right? Because that would take.
I can use it as both, right? So if I want to use it as a PWM, I just drive the DAC to have, it's 4-volt output, and then I pulse it like I normally would.
4-volt output. So if you're dividing this by 2, though, right? So you'll never actually be able to pull this test point or this input to the op amp to 0, right?
Well, I can if well, to do that I just have the DAC would be 0.
Oh, I see. So you're just toggling the DAC on and off. That's how you do PWM. Is that what you're saying?
No, I don't think so. I mean, the DAC output can either be between 0 and 4 volts, and then I can still toggle the fan pulse width on and off, and that will give me. Yeah, you're right though. I can't get all the way to 0 there. Yeah, you're right. You're absolutely right.
Okay. Yeah. So that's still interesting actually, because then you can get kind of like a half-scale PWM, which would be actually kind of interesting as well. You can get like resolution between 50% and 100, right? You get more fine control there. That's an interesting one as well. Yeah, I'm just not sure the use case. I guess this is flexible that we could do either one. I think we need to, if we do the PTC differently, right? We could probably start getting more current through this thing. But I'm not sure what the final use case is. We'd have to calculate how much heat can this thing take, how much heat can the resistor take, and then and how much the PTC will actually let through. Because some people were saying their PTC was firing a little sooner than they thought it would. Nathan, Pedro, do you guys have any feel for what you prefer, a higher current output or a better, finer control for the?
I don't have yet.
For me, more
current. How much current I really need.
Nathan, sorry.
I like more current. I've got a sort of coffee machine I need to drive. So.
Oh, really? that's a lot of current then. What do you you're going to drive like the power through that, like?
There's a couple of 12-volt little coffee machines you can hook up and see if it'll work. But I'm just talking about a use case for it. But
okay.
More current, yes.
Okay. James also wrote in the Q&A section you'd like 250 microamps of current control for semiconductor testing, for testing VI curves, or for generating VI curves, which is actually what we talked about. We talked about doing this with the finer control for the for testing out the opto, right? So actually testing the LED characteristics on the primary side of the opto. So that is another interesting use case. That would be definitely finer control. I'm not sure if we'll be able to get to 250 microamps. That would be basically what our trade-off is. We can go finer control, but then our power is severely limited, right? So I guess that is switchable at that point, right? If we went to a 16 ohm resistor, right? You could put 4 ohms across, or 4 volts across that. you get what, like that's a span of, would that be 250? Would that be right? It's like a quarter, less than a quarter amp, right? So then we get 256 steps within that. So I think the big thing is if we really want to get smaller, we need to buy the 12-bit parts. That would definitely be the biggest thing. You know, we could kind of have the best of both worlds if we wanted higher current and smaller steps if we went to a 12-bit part. But I guess that's where we'd have to pay as well, right? If we want to pay for nicer parts and then also probably more accurate initial resistors for the sense resistor there. Be interesting.
I had a little problem with the driving little current through the Q4. It will get pretty hot, and it will trigger the PTC, which is right under the Q4. So the board gets hot, and the PTC will trigger much too early. I am thinking like putting some kind of standoff between the board and the PTC, like bodging something in there to rise the PTC out of the board.
Yeah, that makes sense. That just like 2 wires or something, have it hanging off the board kind of thing.
Yeah, I thick wire to raise it off the board.
Yeah. Yeah, it's good. I mean, as long as that the heat doesn't creep up the wire, right?
Yeah. We'll have an air barrier there. So
yeah, right.
I'll try it.
Yeah, that is interesting. If we look at the, let's see this. No, it's still on that one. Let me switch over to the layout real quick. Yeah, so it's right under, like you said, it's right underneath that that pad there. So in a best case scenario, we'd probably put this somewhere, you know, far away in terms of heat. So maybe try and squeeze it in here or something like that. Also interesting, we haven't tried attaching the temperature thing here as well. And you know, moving forwards, we might want to. The only downside is that we're using the same op amp for all this stuff, but you know, in a best case scenario, this heat stuff would be very isolated from all of the more sensitive measurement stuff. So, I mean, we'll be able to adjust for it, you know, in terms of temperature, right? We'll be able to measure the temperature on the board, but it's still probably good to have that a little bit more separated.
Yeah, those are the types of things too, like in version, you know, 2 or 1.1 of the Bench Buddy to some of the layout choices, like for assembly reasons too.
Yeah.
Just there's a couple places where vias are really close to the corners of footprints, and you know, maybe moving that thermistor to some place where it's not going to get hot. But it's you know, again, without going through the pain of having problems with some of this, it wouldn't be obvious that, oh, maybe I don't want to do that the next time I do a layout.
Yeah, yeah. You know, we put enough test points in too. With like, speaking of the vias, you know, we probably should have tinted these vias as well, and you know, gotten some solder mask over them, just because we had people doing, you know, early, you know, they're trying soldering for the first time, stuff like that. I personally had problems with this trace right here on my board where I started having the solder mask lift, and I had this trace right here, which is now exposed copper. And it was really close to these pins, so basically that board was done for. Now, granted, I mean, solder mask disappearing in the first place is never a good thing, but yeah, of course, this is not a product, right? That's what it ultimately comes down to, is that, you know, there's always going to be small stuff or even big stuff in some cases like this where it's not going to be a particularly useful first pass or first version. You can't necessarily go to market with it or anything like that.
Yeah. Some labels on those output pins would be nice too.
Oh, on these guys?
Yeah, because I'm constantly having to go back to figure out, all right, what pin is the, you know, ground, what pin is the 5 volts.
Yeah. Yep. definitely true. I don't know where we'd put it. We'd have to either extend the board or something, because this is all exposed copper right here. So.
Maybe the backside.
Oh, that's true. Yeah. Yeah, I guess we could just put it right in there, and especially if we move the PTC and some of these other things. So. What other questions do you guys have?
I did have a question about the for the power filtering stuff on the the left side of the board there. At least the inductor part that I ordered, it was a 105 milliamp part. And I'm just wondering if that's true for the one that other people have used as well.
Interesting.
So I actually ordered some other inductors that had a higher current rating. But
Right.
at least the one I was using, it was low.
Yeah, that actually was determined to be part of the problem for the drop that we saw on the adjustable regulators. It actually was the 2 or 3 ohm resistance of those things that actually ended up affecting it. So I did not look at that specifically. I'll have to look at that before I put another order in, because that could be very useful to change out. How did you find that? You were just looking back at the parts and stuff?
I think a while ago, maybe on the chat, I was maybe chatting with David or somebody, and we started looking at parts, and that came up.
Okay. So James had asked Wes, what did you use for the supply rails on the MCP 3901 L5 inductor? I don't know what that means.
I put a 0 ohm resistor there. I guess that's to tie the analog VDD and digital VDD together. So okay. I just used a 0 ohm.
Okay. So you didn't use the ferrite bead?
I wasn't sure what you had in mind to put there, so no, I didn't.
Oh, was that? I thought we put that on the order. Was that not there?
It was on the order, but I just didn't translate that from what I saw in the schematic to that purpose. If that's what it was for, I definitely have some of those.
Okay, yeah, that is the point. So that's basically just a high frequency choke. I mean, basically the idea is that it's just usually it's 100 megahertz and above kind of stuff even, but it's just good to have a blocking inductor there for high frequency noise between the digital and analog realms. For that spiky, from the edge of basically the a digital signal going out might only be at 4 megahertz or 2 megahertz, but if you look at all of the harmonic frequencies and the fast rising edges, that starts to get up above 100 megahertz sometimes even in the tail. So that's basically what you're trying to get rid of there.
Okay, I think that might be something that didn't get back annotated into the schematic.
Interesting. Like the actual part number, or you mean the
yeah, the actual part number.
Ferrite bead. Yeah, usually that probably was a bad idea to call that L. Usually you'll see that on schematics as FB for ferrite bead. It'll still be drawn as an inductor, but usually the prefix for the reference designator will be FB or similar. And usually for analog to digital converters, I usually put those on the analog rails as well. You'll see that pretty commonly. Any other questions?
Just a quick one, Chris. The week to come, what's installed for us there?
So the week, so first thing's going to be this secondary order and checking out that stuff, seeing what we need. Another will be getting the MCP. So obviously, some people have had the MCP 3901, but put down, but basically getting that down. The other part of the order is making sure we get a crystal on order in order to actually start taking some readings, doing some preliminary things there, and then starting in on the LED circuit as well. And then from there, we also have to, I guess I could turn the screen off and show here. So we still have to test the secondary FET here, where we disengage the sense resistor. right? And then actually drive it as a voltage output. And that will be interesting as well because that'll interplay with the PTC on the back, the TH5, and because that'll be actually our main limiting current thing there. And I think past that, I mean, it's kind of starting to get together a more cohesive program as well. I know that it was Tommy that started writing more of a framework for actually like writing a program in order to get menus and that kind of thing as well. And then after that, I'm not sure. I mean, I'm sure we're going to run into enough problems with the initial stuff that we'll have to figure it out from there. We do also have to, like I said, this little stinker on the back as well, right? That U5, that's or U3 rather, the temperature sensor. That'll be another one, but really until we get the ADC in there and up and running, it's kind of a moot point. So.
That one is sort of fun though because you can connect it up pretty simply and read the voltage out of it, and then go look that up in the table and say, oh yeah, that matches what I would expect.
Cool. Okay.
One other thing, if you're making that order sheet, is I also realized that there is the need for these external load capacitors for the crystal for it to start oscillating correctly.
Oh, interesting.
It's not just as simple as putting the capacitor or the crystal in there. There's some load capacitors needed to go to ground from there. So you might want to take a look at that as well.
Okay, definitely.
I'm new to this whole clock crystal thing, and
yeah.
So I'm figuring it out as I go, sort of.
And actually, that's another in terms of that order sheet as well. There's a couple other things that have been kind of lingering. What else do we need? We need bodge wires are another thing, right? I've been using these because we haven't ordered any 20 or 22 or 30 gauge wire like we mentioned. That is a good thing to have in your lab. So just kind of getting that on the sheet. Another thing is that for the LED circuit, we don't actually have any LEDs to test with, right? So we need to get those on order as well in order to. We actually want to light stuff up. I can't just necessarily guarantee that people have it in their labs as well. So, yeah, I think that's kind of all on the list of things to get. I don't remember if there's any others that needed. I mean, I don't know if you guys saw the thing about the heat gun? Do you have any interest in getting one of those?
Yeah, looks like a handy piece of tool to have in my kit as well. So I've never used one before, so I'll be having a look at that.
Okay. Pedro?
Have you thought about the mechanical stuff as well, Chris? Really like maybe standoffs?
Oh, sorry. Let's go Pedro first, and then we'll come back to you, Nathan.
That looked a bit grunty.
It's very grunty.
Yeah.
Yeah, I mean, best case scenario, you get an actual hot air pencil, right? A hot air reflow station. If you want to, spend the money, the AOUE actually is pretty good for the money. But yeah, try and keep low cost tools.
The one that they've got, the 810, I don't know the rest of the reference number. It's about $80, I guess.
Yeah.
I'll look into that.
Okay. So Nathan, you were mentioning standoffs. Did you mean these standoffs here, like for the actual mechanical side of things, or you mean the Arduino standoff?
No, the mechanical stuff. I noticed a couple of people have standoffs, so the board lays a little bit more stable on the bench.
Okay. Yeah, that's a good one to start looking at as well. Yeah, I haven't seen anyone. We haven't really looked at like a case design or anything like that yet. I'm not sure if that would be the time to do it even because it's still prototype. If we decided to in the version 2, we start talking about what can we do to make it smaller, maybe more compact or anything like that. Maybe that would be the time to really do it. But yeah, in the meantime, having standoffs for having it sit there when it's not plugged in, or even when it is plugged in to the Arduino, having it just nice and tall, that can be helpful. You don't have to have a board holder at that point. I'm wondering, do you think my assertion that the low cost is a necessary thing, is that a stupid assumption? It seems like everyone's like, oh well, don't want to buy these smaller things, but I guess my assumption is that you know, if people are paying for the course and buying the parts and everything else, it's like don't necessarily want to have huge equipment costs either, but maybe the fact that people are self-selecting is taking the course in the first place, that's you know, an indication that they're willing to buy some good gear and have some decent gear.
It's an interesting thing for me. It's about cash flow. So sometimes I can't afford everything up front, but you know, if I project out to say week 6 we're going to need this, this, and this, then you know there's time to get the funds together and put the order in.
Okay. Yeah, that's a good point. Yeah, because then it's not like one huge bulk order up front. It's kind of a habit you can't kick, right? Hardware is a habit we just can't kick.
And there's enough things on this bench, buddy, that you could even say, look, you know, you're going to be able to assemble 2/3 of what's on here using, you know, soldering iron and solder wick and everything, and then for the last third, or maybe even, you know, last quarter, it's advisable that you have these other tools, but you would still get this functionality out of the board even if you don't.
Yeah.
So,
Okay.
I mean, that's also a reasonable way to go, I think.
Okay. All right, cool. Well, I don't like if you guys saw the email. We will be having a second session tomorrow. You guys are welcome back, of course. So that'll be 3 p.m. Eastern time. Pedro, I think that might be. Oh no, I guess it's still kind of early for you, right? So you're 6 hours ahead. Nathan, are you where are you at? Are you?
It's 3:03 in the morning here in Australia.
Okay, so that will be a little later than late tomorrow. So you Aussies are very dedicated with the late night stuff. So okay, so yeah, so we will be having another session tomorrow. If people are catching this video, you know, between now and then, we'll have a second session there and try and catch all the people that didn't see the updates. But I'm glad you guys showed up today. It's been as helpful for me as hopefully it's been helpful for you.
Hey, one last thing I wanted to throw out, Chris, is you're doing some more programming. I ran into some issues where I was power cycling my bench buddy, but not necessarily the Arduino. And you know, depending on how you're initializing some of those chips and talking to them, it can get out of sync with the state of what the Arduino thinks things are in versus what the actual board is.
Yeah.
So that's just something that burned me as well.
That's interesting, and you know that I talked about the MCP. If we don't actually, people can't get that, we could wire that over here, right? But another thing we could do is we could take the 5 volt that's coming from the ATX, wire that over to here, and then use that as a power monitor, right? So that could be a future enhancement as well. That you know, power monitoring, so that you could go out and check. Is 5 volts there? Is the ATX alive? Even though the Arduino might be running off USB or something like that. So that could be a good sanity check, that kind of thing.
Yeah, that could be, because right now there's sort of, it's a one-way street almost of, am I talking to anyone out there? Can you hear me? I hope you're doing what I tell you to do.
Right, right. Yeah, that's a common problem in any system like this, any digital analog combined system. You know, having some kind of actual real life feedback, then you actually close the loop in the system. So that's very important. Cool. All right. I guess we haven't done that as well either yet. So that might be another thing we do this week, Nathan, is start monitoring the actual. We can monitor the divided voltage from the adjustable output as well. That could be another way to test. You know, is it alive? If this is 0 at this point, right, Wes? It's probably pretty realistic that it's dead. You know, something's going on out there. So. Okay, cool. Well, we'll be back tomorrow, 3 p.m. Eastern Time. If you guys can make it, then that means Nathan's probably not sleeping very well. All right, it's good seeing you. Thanks for hanging out today.
All right, bye.
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 See you.